Picture the most high-tech freight network on the planet. Mile-long trains, steel rail welded into ribbons that run for miles, locomotives tracked by satellite, billions of dollars of cargo moving every day. Now look down at what holds all of it up. Wood. Plain wooden beams, the same idea railroads used before the Civil War. You would think somebody would have upgraded by now. But railroads have had concrete, steel, and plastic as options for decades, and they still choose wood for more than 90% of the track in America. So the question is simple: why? And the answer is a lot weirder and frankly a lot smarter than we just never got around to it. To see why wood keeps winning, you have to understand what these beams are actually doing down there, because it is far more violent than it looks. Standard railroad track in America is built to a gauge of 4 feet 8.5 inches, and that exact distance has to stay exact, mile after mile, year after year, no matter what rolls over it. What rolls over it is brutal. A single loaded freight car can drive tens of thousands of pounds straight down through one steel wheel. A fully loaded big boy and its tender tipped the scales at about 1.2 million pounds, all of it balanced on thin strips of steel. Left on its own, that rail would knife straight down into the dirt. So something has to absorb that punishment and be ready to take it again a few seconds later, and that something is the crosstie. It has 3 jobs to pull off at once. It clamps the 2 rails the correct distance apart so the gauge never wanders. It keeps them from rolling over sideways under the shove of a passing train, and it takes that savage point load and spreads it across the bed of crushed stone ballast underneath, so the ground can actually carry it. Underneath those ties sits the ballast, the bed of sharp crushed stone that locks everything in place, drains the rain away, and lets crews fine-tune the exact height and alignment of the track. And the rail does not even touch the wood directly in most cases. It rests on a steel tie plate that spreads its bite across the surface. Every layer in that sandwich exists for one reason: to take a punishing concentrated load and hand the earth something it can actually bear. There are roughly 3,000 of these ties in every single mile of track, and every one of them gets pounded thousands of times a day in blazing heat, deep cold, rain, and ice. Whatever you make them out of has to survive that beating for decades on end. So the real question was never what looks modern in a brochure. The question is what genuinely holds up when 100 million pounds a day is trying to tear it apart. This is where wood does something concrete simply cannot. Wood flexes. When a heavy wheel rolls over a wooden tie, the wood gives a little, soaks up the shock, and springs back into shape. That tiny bit of give is quietly doing an enormous amount of work. It cushions the rail, the ballast, and the train itself, smoothing out a blow that would otherwise hammer everything to pieces. Concrete does not flex. Concrete is stiff and rigid, which sounds like pure strength right up until you remember what rigid things do when you hit them hard enough. They crack. Track crews will tell you that a dragging wheel or a chunk of broken equipment can snap a concrete tie clean in half, while the very same hit just gouges a wooden tie and leaves it sitting there, bruised but still doing its job. A chewed-up wood tie is ugly, but it is still holding gauge. A cracked concrete tie can turn into a derailment waiting to happen. There is also the matter of weather. Wood handles the endless cycle of freezing and thawing and the wild temperature swings of a continental climate without much drama, expanding and contracting and shrugging it off. And because each wooden tie has a bit of natural spring to it, the whole track behaves a little more like a suspension system than a slab of pavement. So wood ends up being the tough one in this story, the option that takes a punch over and over and refuses to quit. But toughness is only half the story. The other half is the thing nobody puts in the brochure and everybody secretly cares about most: money. America has an almost absurd amount of railroad, more than 200,000 miles of track, which works out to somewhere around 600 million wooden ties sitting in the ground right now. Multiply 3,000 ties a mile across an entire continent, and the replacement bill gets terrifying in a hurry. This is where wood quietly dominates. Wood is cheap, it grows on trees, which is not a joke. It is the entire point. The country is full of the oak and other hardwoods that make excellent ties. A wooden tie is light enough that a small crew can wrestle it into place by hand. It is cut from timber that mills are already cranking out anyway, and once it is soaked in creosote, that thick coal tar preservative you can smell on a hot day near the tracks, it shrugs off rot, insects, and fungus for 30 years or more. In the wettest, most rot-prone stretches, railroads go a step further and treat the wood twice. First with a borate compound that fights decay from inside the beam, and then with creosote to seal it, wringing even more years out of a single tie. The tie industry in North America can crank out well over 20 million cross ties a year just to keep the network fed. Concrete ties, by contrast, often cost 2 to 3 times as much a piece, and they are so heavy that you essentially need machinery just to pick one up. When you are swapping out millions of ties every single year, the phrase 2 or 3 times more expensive and far harder to handle turns into a number that makes railroad accountants reach for the antacids. For a freight railroad, the cheapest tie that does the job well is almost always going to win, and for a century and a half that tie has been wood. But the money story is not only about the price tag on a new tie, it is about how forgiving wood is once it is actually in the ground. Imagine a track crew out in the middle of nowhere with one rotten tie that has to come out. With wood, that is almost a casual afternoon. You pull the spikes, slide the dead tie out, slide a fresh one in, drive the spikes back home, tamp the ballast, and roll on. No crane, no exotic fasteners, no factory-level tolerances. Wood also does not throw a fit if the ground underneath is a little uneven or a little soft, because the tie itself can absorb the imperfection and the crew can adjust on the fly. Concrete is far less relaxed about all of this. A concrete tie demands a carefully prepared, precisely shaped bed of ballast and a whole system of spring clips and rubber pads to grip the rail, and it tends to punish you when the conditions are not just right. It is heavier to move, fussier to install, and harder to fix one at a time. Wood just sort of deals with whatever you throw at it. For a railroad threading through deserts, swamps, mountain passes, and farmland, often miles from the nearest road, that easygoing repair it with a spike maul attitude is worth an absolute fortune in saved time and labor. Now, before every concrete fan in the comments grabs a pitchfork, concrete absolutely earns its keep, and in the right spot, it is clearly the smarter pick. Concrete ties are heavy and stiff, and that stiffness means they lock the track into position with pinpoint precision, and they barely budge under load. That rock-solid steadiness is exactly what you want when trains are flying along at over 100 miles per hour, because at those speeds, even a tiny wiggle in the rail becomes a serious problem. Concrete also pairs beautifully with modern continuous welded rail, helping resist the track buckling that summer heat can cause. That is precisely why Amtrak's high-speed Northeast Corridor rides on concrete, and why most of Europe and a lot of Asia, where passenger trains are fast and the cities are packed close together, now build almost everything new with concrete. The shorter hauls over there even make those heavy ties cheaper to ship to the work site. On paper, a concrete tie lasts around 50 years, roughly double a wooden one, while needing less routine fussing in between. Its sheer strength means a line can sometimes get away with fewer ties per mile. So if concrete is more precise, plays nicely with welded rail, and lasts twice as long, you would expect American railroads to be tearing out wood as fast as humanly possible. They're not even close. The reason comes down to one spectacularly expensive lesson that played out on the busiest railroad in the country. If you are enjoying this deep dive, take 2 seconds to subscribe. This channel takes apart the strange engineering behind trains every single week, and there is always more weirdness where this came from. Now, let me tell you about the time concrete ties absolutely humiliated themselves. Back in the 1980s and 1990s, Amtrak installed hundreds of thousands of brand new concrete ties along the Northeast Corridor, the jammed stretch of railroad that links Washington, Baltimore, Philadelphia, New York, and Boston. These ties were supposed to be the future. They carried a service life rating of around 50 years. They lasted closer to 10. One Amtrak spokesman summed it up perfectly when he said they were supposed to last 50 years and they only lasted 10. The concrete was quietly destroying itself from the inside out, the victim of a slow chemical reaction in the material known as alkali-silica reaction, where the aggregate inside the concrete reacts and expands until the tie cracks itself apart, all of it made worse by the enormous internal stresses packed into a pre-stressed tie. Investigators traced the worst of it to ties whose top row of steel tendons cracked horizontally inside the concrete, and the company that made the defective batch ended up on the hook to swap out enormous numbers of the ties it had sold. Around 350,000 ties from that first era of trouble failed, and then a separate wave of manufacturing defects put roughly 800,000 more on the death list. Amtrak has poured tens of millions of dollars into ripping out the bad concrete and putting in fresh ties, and in the meantime, crews have had to slow trains to a crawl through the worst sections, sometimes down to 10 miles an hour on a railroad that is supposed to be fast. And this is the detail that should keep every railroad up at night. When a wood tie wears out, it does it slowly and politely, and you replace it on a quiet Tuesday. When a concrete tie goes bad, it can go bad by the hundreds of thousands, all at roughly the same time, and the bill shows up with a frightening number of zeros on it. Wood fails gracefully. Concrete fails dramatically. So why does Europe run happily on concrete while America stubbornly clings to wood? The two continents are simply solving very different problems. Europe runs fast, frequent passenger trains across relatively short and dense networks where concrete's precision pays off, and the modest shipping distances keep those heavy ties affordable to move. America runs staggeringly heavy freight across a gigantic network, often through remote and punishing terrain, where wood's toughness, low cost, and easy one-at-a-time repairs win the arithmetic almost every time. There is also a history baked into the ground. The American rail network was largely built out during the wood era, and today it is mostly maintained and patched rather than ripped up and rebuilt from scratch, so wood is the reigning champion and it keeps defending the title every maintenance season. Then, layer on the climate. Huge swaths of the country swing from brutal summers to frozen winters, and a wood track structure tolerates that abuse and the constant freeze and thaw with less drama than a rigid concrete slab. Add the sheer weight of American freight, some of the heaviest in the world, pounding down day after day, and you have conditions that reward a material that can flex and take a beating. For most of the track in this country, the math keeps landing in the same place, and that place still says wood. None of this means wood reigns forever. Steel ties already show up in specialized spots and tight clearances, where their slim profile and strength come in handy, and that thin profile can even cut the amount of ballast a line needs, which is a genuine perk inside tunnels and other pinched spaces where every inch of height counts. Engineers are getting genuinely serious about composite ties molded from recycled plastic, which aim to outlast wood while dodging concrete's nasty habit of cracking. Concrete is slowly expanding onto the heaviest and fastest corridors, exactly where its strengths matter most. The newest generation of concrete ties is being deliberately redesigned to be less rigid, with engineers chasing a reduced stiffness so the ties stop cracking themselves to death. In other words, after decades of trouble, the cutting edge of concrete tie design is quietly trying to make it behave a little more like wood. Meanwhile, across the overwhelming majority of the country, the humble creosote-soaked wooden beam just keeps on quietly winning, one freight train at a time. So the next time you are stuck at a crossing, watching a mile of train rumble past, and you glance down at those plain old wooden beams and think the railroad is just being cheap, remember what is actually happening under there? That wood is flexing under 100 tons, absorbing impacts that would shatter concrete, getting swapped out by hand with a few spikes when its time comes, and pulled out for a fraction of the cost across a network the size of a continent. It is not a leftover from a slower age. It is a choice, made over and over and over again by people who have run the numbers and keep arriving at the same stubborn answer. Here is what I actually want to know from you. If you were the one laying down new track tomorrow, the budget was tight, and the terrain was rough, would you trust wood, or would you bet it all on concrete? Drop your answer in the comments and tell me why you picked it, because I have a sneaking suspicion this one is going to start a genuine fight down there.